So next what we have is the dimension continue, wherein is similar to this, but instead of taking the baseline, it continues from the originating dimension. So let us come back to this point dimension and let us dimension on this edge to differentiate between them. So let us use for the dimension continue option CO. So from this you can see it is referring to this point. Okay, so now let us start off with this. So let us put a dimension linear 1, the first dimension here, and then let us call the dimension continue. Now you can see the dimensions are continued from the previous endpoint, and that endpoint is considered as the start point here. So we'll go about for the same in dimension angular and see how it's positioned here. So let us position in this way to differentiate between this. So now going for dimension continue. Now you can see that this gets continued from this one. So this is how the dimension baseline and dimension continue is going to vary. Then again recollect like how we are going to give the dimension annotation onto the drawing. So it gives the designer as well as the inspector ways to analyze the key design. So the thing is, when you give out a baseline dimension, then it means that this surface, this feature is going to be of prime importance for them, and all other feature boundaries are referenced from this feature line only. So this is the information that you are trying to say in the dimension baseline command. Whereas in dimension continue command, what you are saying is the each and every dimension is going to be controlled, and hence whatever the endpoint is, it's also a critical dimension. So each and every facets of this feature needs to be controlled. So this is how differentiating between a baseline and a dimension continue modifies the pretext of measuring the feature at the end of the line. So you need to be very careful of how you give out the dimension. It's not on the ease, but rather how to measure it on the end of line or during inspection. So next we have the ordinate dimensions. So these ordinate dimensions will measure the horizontal or the vertical distance, that is the x or the y distance from an origin point. That is what we are seeing as the datum. So this datum we'll look in the next week session during this tolerance part. But datum is something like a reference from which you have to start the measurements. So for example, if you are locating a hole or a search, so you refer to one such reference planes and then do it. So that is called as a datum. Suppose if in this diagram you see, if you want to ensure that the location of these features are have to be controlled, then you have to use this dimension ordinate features so that we eliminate errors by maintaining the accurate offsets of those features from the datum. So in order to call this function, we have the dimension ordinate, DIMORD. So when prompted, it will ask for the feature location. So considering this feature, and we have to locate the center of this hole, then we can select this feature point. So once that's done, you can see that based on the movement of your cursor, it changes for the x and y coordinate. So what it means that this point 270.54 is the x coordinate distance from the datum plane. So currently now the datum plane is considered as this the local US. So from this point it is 260, whereas on the y-axis it is 386.17. So this is done with reference to this plane. So by positioning it, you can vary the mark the datum plane. So if you do not want to do it, and if you want to make the datum plane fix the datum surface, that is you want the datum plane surface to lie on these two axes, then you have to move your global reference here to here. So that can be done by using modifying the coordinate system reference point, that is the user coordinate system. So in order to do that, you can invoke that by the UCS command, user coordinate system. So now it asks for switching of those points. So now as ortho mode is on, we'll turn it off. Now we can see that the datum is extrapolated from its original surface, and now you can specify the new origin of this datum. So let us position this at this corner edge so that the x and y axes are aligned with these two surfaces. So once we fix it, then it also asks for the rotation or the intercept of the x-axis. So we can click on enter or select the point on the same line to retain it. Now you can see that this user coordinate, you can see this the coordinate system has disappeared from here and has moved on to here. So typically if you refer some datum plane here, it will go in the negative direction because this is on this quadrant. So now having said that, we have moved the UCS coordinate. Now let us call the dimension ordinate command again and then position this. So now you can see that you have the x and y feature modified and it references with this plane. So by this dimension coordinate, you can dimension the critical features with reference to the datum plane so that they can be controlled during the production or machining process. So you can see that this is a part of a leader line. So the leaders will look into the next part. But here as in leaders, you can see that there is this jogged portion of this leader. So in order to eliminate this, that is if you want to have it in a straight line, then you can invoke the ortho mode F8 so that it is perfectly 90 degrees to the point. So this is your x and y datum plane. But right now we have just picked a feature point and then selected. So alternatively, what you can do is after selecting the feature location, instead of specifying the end point of the leader, you can specify it, override it as an x datum or a y datum. If suppose we select the x datum, only the x datum point will listed and you can position it accordingly. So if you want to position in this way, and then you can change the angle or the text content using these commands. And if you want to go for the y datum, then you can go for this. So this is the dimension ordinate feature. So next we'll look at the dimensioning of an arc length. So earlier what we had seen was the dimensioning of the arc end-to-end reference point using the command dimension angular. So with dimension angular, we measure the end-to-end angular dimension between those 2 points. Now we'll measure the arcual length. So towards this, let's just construct an arc. So considering this as the start point and the center point as here. So consider this as the arcual element. So then invoke the dimension arc command DIM-ARC. So now once you select this arc and then position this extension line, you can get the arcual length. That is also highlighted by this symbol that highlights that it's an arc length. Whereas if you invoke the dimension angular command and if you select the same arc and such, it denotes the angle between the start and end points of this arc. So this is how you can use the variations of this command to dimension your component. So based on the requirement, suppose this feature is required to control the arcual length of the feature, then you can reference it using this dimension arc. Or if the endpoints are of critical and they have to maintain at a certain angle, then use a dimension angular command. Again reiterating, whatever critical dimensions that you want to measure or control is what we have to dimension on the drawing. So far we have seen the major dimensioning techniques. So let us quickly review them. So in this dimension tab, we have looked into the linear dimension, align dimension, arc length, and also ordinate. And we have seen dimensioning the radius component, diameter and angular, also with this baseline type of dimension and continuous dimension. So now let us look into slight variation of this dimension to modify the existing dimension to suit our requirement. That is, so first we'll start off with jog dimension. So there we have a jog radius or a jog linear. So this is like modifying the existing dimension to suit to the current view that we have. So that is your jog dimension. Then controlling the spacing between the various dimensions, that is done using dimension space. And suppose if the dimension runs through the object, if you remember our rule is dimension should not pass through the object and it should not cross each other. But if there are some cases when the line actually crosses through, then you can use this dimension break to eliminate any crossing with the object. You introduce a break to the dimension extension line. So that is the function of this. And then we have this jog linear dimension. Then also next additional thing is like for inserting any inspection dimension. So we'll look into these sections now. So first to start off with the jog to radius dimension. So jog to radius means that it will measure the radius of the selected object and displays the dimension text with a radius symbol in front of it, just like our normal radius dimension. But the difference is that we can alternate the origin point of the dimension line to any specific location. So this is going to be used when, suppose if you are going to dimension this object, wherein my paper space is just going to be here, that is the center width out of the scope of this layout. Then in those cases, if it's difficult to dimension the part, then we can use this jog radius dimension so that the origin point, instead of here, the reference is shifted to a convenient location. So towards this, so we use this dimension jog command. So on selecting the R for the circle, it prompts for the center location override. That is, we specify the new center. So suppose this dimension needs to be referred from this point, then you can see from this point, now the radius goes for the second. So it asks for the dimension line location. Where should that dimension, the text should get located. So in this case, like say if it goes on 3, the next requirement is to specify the jog location where this jog should go in. So suppose if we are pressing it here, now we can see that this object is referred to from this point. So this is your jog to radius dimension used in cases where the feature is extraordinarily large and does not, its origin is not covered within the given layout. Then you can use this jog radius dimension to convey that factor that it is a large dimension object. So likewise, we also have the dimension jog for the linear segment. That is, suppose consider a very large line. Let us look into this example here. See, the total distance here is around 150-160 mm. Okay, but suppose these are in meters. Okay, so in that case, or the scale is very large. So in that case, we cannot dimension those parts. So what we can do is we can create a jog linear dimension, jog linear line, so that to jog an existing dimension. That means that, see this dimension, let us say this is of large units. Okay, so in that case, if I'm introducing a jog, I'm clicking the dimension line. Now next specifying the jog location. So once this is done, you can see that it is modified. So it means that there is on the drawing the physical distance might be say only 5 centimeter, but rather here it denotes a longer range. Suppose it is like say 5000 meters. Okay. So this is how the true distance between this dimension length is a different value, but we are overriding that with using this jog linear dimension command. So this is to used for specifying unmeasurable quantity on the physical drawing. So alternatively, we can also remove a jog line. So you can invoke the jog dimension line. So on the dynamic option, you can see this. There's a remove option here. So once you click on a previously jogged line, you can remove this jog command. So this is an adding or deleting the jog line. And suppose if we want to modify this location of the jog, you can select this and then use this the dynamic input object the grips so that you can modify the location using this grips. So this is the optimizing the jog location. So this is about the jog linear. So likewise you can also invoke jog angular command. So dimension jog angular. Now this introduce the angle of this jog line. So currently 45, this you can override. So this jogging is used for a linear or the radius elements. So this is about jog lines. So next we look into the dimension space to improve the readability of the text. So consider this part. You can see the when we are demonstrating the baseline dimension, the continued dimension, you can see that that's an overlay of the text here and it hampers the readability because here the text and the arrowhead are interfering with each other. So typically what we will be doing is we will be selecting this and using this grid to modify the location. So instead of that, we can use this dimension space command to alter the dimension spacing. So for that, the first requirement is to select the base dimension. So once that base dimension is selected, next requirement is select the other dimension to space with reference to the base dimension. So now you can select all others. So upon selecting it, click on enter. So now it asks for a spacing value for this dimension line or an auto command. So by default you have this auto command selected. So when you go with this auto command by clicking on enter, you can see that the dimension lines are equally spaced and this height of the spacing is determined based on the height of the text of this line. So based on this text height specified in this dimension style, that will get multiplied twice so that the resulting height between these two lines is the twice the height of this dimension style. So this is your dimension spacing. So alternatively, you can also space by your user specific value. So suppose if we want to keep this spacing to say 5 units, then it will get aligned. So I think the values are already in 5 units. Yeah, that's it, because the in dimension style height, suppose if we double click it, you can see this the dimension height is 2.5, so twice that is 5. So that is why we already have got the same dimension height. So let us go ahead and say a differential height of say 8 now. So now you can see that the spacing has been increased to 8. So this dimension space command can be used extensively to make sure the dimensions are very well in readability, because at the end of the day, the production specialist and the inspection specialist should be able to easily understand the dimensions and drawing intention. So this is the dimension of the spacing of the dimension element. So next what we have is the breaking of the dimensions. So this dimension command, the break command, will break the dimension or the extension lines whenever they intersect any object or other dimension. So supposing we have a line, that passes through this object, something like this. Okay. So in this case, so this overrides or rule of dimension that this dimension should not pass through any object. So in this case, we can invoke this dimension break command. So with this dimension break command, you have to select the dimension which passes through this object. and then select the object to break the dimension. So this is the object for the dimension break to happen. So once selected, you can select this object and see, because this was the selected line, and you can see that there is a break introduced between this line. And likewise, when you selected this object, this has been introduced as a break. So this is what, okay, so there is one more line here. So let us remove this. Okay, so that was a part of our object. Yeah, so now it's very clear now. So what happened is, the dimension extension line has introduced a break so that it does not interfere with this object. So this is your dimension break command. So suppose if there is no object and this object has been removed from its place. So let us move this object here. Now you can see that the break command automatically closes it. So this is the auto break dimension break command. So inside this dimension break, we have a facility to add or remove the break line, and also multiple introduction of the dimension break commands. So this command can be extensively used for dimension line as well as leader objects, and it can be applied to the linear dimensions, either aligned or rotated, or angular dimensions, all the radial dimensions, that is radius, diameter, jogged commands, and arc length dimensions, ordinate dimensions, and then also applies to multi-leaders, that is in case of the straight lines, or Ligus leaders, that goes for straight or spline lines kind of thing. So this is what the usage of your break command. So dimension break. So you can see as this dimension is already associated with the dimension break command, whenever there's a object in its place, the dimension gets break accordingly. So next what we have is the specification of the inspection dimension. So inspection dimensions vary from our normal dimensions by specifying how frequently the manufactured parts should be checked to ensure that the dimension value and the tolerances of the part are going to be within the range. So instead of adding a separate note, that the number of frequency of inspection can also be included in the dimension line itself. So these are related to tolerancing. We'll look into the next part, but right now let us use the inspection dimension command to specify how frequently the given dimension has to be measured. So that is invoked by the command dimension inspect. So this opens a dialog box that has the following options. The first is to select the dimension that wherein the inspection details have to be inserted. So once done, then what is the shape of the box that is denoted? So either the round or angular or an enclosure or none. So, and then what label needs to be specified. Suppose if we have different numbers of the inspection dimensions, then you can label each and every one of the dimensions for quick reference. Then you also specify what is the inspection rate for that dimension unit. Suppose if the inspection rate is 50%, then it means that that given dimension should be measured 50% of all the components produced. That is, if you are producing 100 components, for 50 of those samples, you have to measure this dimension. So this is what information is conveyed through this dimension line. So towards this, let us select this dimension. Suppose we are selecting this one and click on enter. Now it prompts back this dialog box, and let us go with the same, the frame for this inspection dimension is round, and we'll introduce a label, say this is label A, and with an inspection rate of 50. So the dimension text is replaced with this dimension inspection frame with the label and the inspection rate. So this is your inspection dimension.